Have you ever thought about why quantum computing is a big deal and why it's so tricky to make it work right? Why do these super-fast computers often mess up? Today, we're going to talk about something cool from Microsoft, the Majorana 1 processor. It's a new invention that might finally help us use quantum computers for everyday stuff. But is it actually going to work? Or is it just a lot of fancy talk? Let's find out. What is quantum computing? Let's break it down. Imagine a super-duper fast type of computer that can solve big puzzles much faster than the computers we use at home or school. This kind of computer is called a quantum computer. Unlike regular computers, which use bits as the smallest pieces of data, these bits are always either a 0 or a 1, quantum computers use qubits. Qubits are special because they can be both 0 and 1 at the same time, which lets them do lots of calculations all at once. But quantum computers have some big problems. They are very fragile, meaning they don't like any disturbances. Even a tiny bit of heat or unwanted noise can mess them up. This makes them make mistakes in their calculations. Think of it like trying to do your homework in a noisy room where you can't focus. Because of this, scientists are working really hard to figure out how to make quantum computers strong and error-free so they can be used for important tasks without messing up. Let's talk about Microsoft's Majorana 1 processor. This is a very special type of computer brain called a quantum processor, and it's the first one in the world to use something called topological qubits. What's so cool about these topological qubits? Well, they are not like regular qubits that most quantum computers use. Regular qubits can easily make mistakes if there's even a little bit of disturbance around them, like heat or unnecessary noise. Topological qubits, on the other hand, are much tougher. They don't get confused as easily, which means they can do their job better and make fewer mistakes. What helps these topological qubits to be so strong? It's all thanks to a special kind of material called a topoconductor. This material helps create a new state of matter that is perfect for handling quantum information, the kind that quantum computers work with. By using this topoconductor, Microsoft's Majorana 1 can keep its qubits stable and reliable. This stability is a big step forward in making quantum computers more practical and useful for all kinds of complicated tasks. Have you ever wondered how Microsoft's Majorana 1 processor stores and reads all that important quantum information? Well, it uses something really cool called Majorana Zero Modes, or ZMs for short. Think of ZMs as tiny, super smart particles that are really good at holding on to quantum information without letting it get messed up. This is super helpful because keeping information safe and stable is a big challenge in quantum computing. Now, how does the Majorana 1 actually read this information? That's where quantum dots come into play. Quantum dots are like tiny counters inside the processor. They check the information stored in the qubits by measuring small changes in electrical charges. It's kind of like checking if a light is on or off. These quantum dots are very careful not to disturb the qubits too much, which helps keep the information accurate. By using Majorana Zero Modes and quantum dots, the Majorana 1 can handle quantum information in a stable and reliable way. This helps it perform complex calculations much better than other quantum computers, which often struggle with errors and stability. Microsoft has a special way of building their quantum computers that makes them really cool and useful. They use topological qubits, which are a bit like superheroes among qubits because they are naturally more stable. This means they don't get mixed up or make mistakes as easily as other qubits do. Imagine if you had a superpower that let you do your homework in a noisy room without getting distracted. That's kind of what these topological qubits can do. Because these topological qubits are so stable, Microsoft doesn't need to use as many of them to fix errors. In most quantum computers, a lot of extra qubits are needed just to make sure the main qubits can do their job without errors. It's like needing a bunch of extra pencils just in case some of them break. But with Microsoft's topological qubits, you need fewer extra pencils, so to speak. This means the quantum computer can be smaller, simpler, and more powerful. With fewer qubits needed for error correction, the calculations done by the computer are more reliable. This reliability can help do important jobs like solving big problems in science and medicine much faster and more accurately than ever before. Let's compare how Microsoft, Google, and IBM make their quantum computers. Each company has a different way of building these super cool computers, and they face different challenges too. Microsoft uses something called topological qubits, which are really good at not making mistakes. This is like having a secret formula that makes their quantum computer super stable and less likely to mess up. Google and IBM, on the other hand, use a different kind of qubit called superconducting qubits. These are also pretty amazing, but they have a big problem. They make more mistakes. To fix this, Google and IBM need to use lots of extra qubits just to correct errors. Imagine needing many erasers just to keep one pencil drawing perfect. That's what it's like for Google and IBM, which makes it harder for them to build big, useful quantum computers. The big challenge for Google and IBM is to figure out how to make their computers work well without needing so many extra qubits. Microsoft's topological qubits already don't need as many helpers, which might give them an advantage in making quantum computers that are ready for real-world tasks faster than the others. Have you heard of DARPA? It's a very important part of the US government that helps create new technology. DARPA works on cool and advanced projects, like the early internet or GPS, which helps us find our way around. Now, DARPA is helping Microsoft with their quantum computing technology by giving them support and approval. This is a big deal because when DARPA thinks a new technology is good, it means it's really promising. Why is DARPA's support so important for Microsoft? Well, it shows that experts believe Microsoft's new quantum computer, the Majorana one, could change the way we use computers in the future. DARPA doesn't just support any project. They choose the ones that they think can really make a difference in the world. Their backing is like getting a gold star on a really hard project. It tells everyone that this quantum computer isn't just a cool idea. It's something that could actually work well and be useful for lots of different things. So, DARPA's involvement is a big thumbs up for Microsoft. It means they're on the right track to making quantum computing something that's not just in science books, but part of our everyday lives, helping solve big problems much faster than ever before. Quantum computing isn't just about making computers faster. It's about making them smart enough to solve problems that are too hard for regular computers. Let's look at some ways quantum computers could really make a difference in the world. In medicine, quantum computers could help doctors find new medicines much quicker than ever before. They could simulate how drugs work inside our bodies, speeding up the process to discover treatments for diseases like cancer or Alzheimer's. In the world of energy, quantum computers could help create better batteries and more efficient solar panels. This would mean less pollution and more clean energy for everyone. In cybersecurity, which is about keeping computer information safe, quantum computers could both create new risks and solve them. They could break some security codes that protect our information, but also help make new codes that are even stronger. Lastly, in artificial intelligence, AI, quantum computers could train AI systems faster and better. This means smarter robots and AI tools that could do things like improve traffic, help in emergencies, or even assist doctors in surgeries. So, quantum computing could really change a lot of industries, making things safer, faster, and more efficient. It's like having a super tool that can help fix many of the world's big challenges. Microsoft has a big plan to make their quantum computers better and better until they can do amazing things. Right now, they are working on starting with small experiments and gradually making their quantum computers bigger and more powerful. This plan is like building a really complex Lego set, where each step needs to be put together perfectly to create something awesome at the end. Their main goal? To build a quantum supercomputer that has 1,000,000 qubits. A qubit is a tiny part of a quantum computer that helps it think and solve problems. Having 1,000,000 qubits would be a huge deal because it would make the quantum computer incredibly powerful, like having a superbrain that can solve massive problems no regular computer can handle. Microsoft's journey starts with creating a small quantum device called Tetons, which has just 1 qubit. Next, they want to make a slightly bigger system with 8 qubits to see if they can work together without making mistakes. This step is crucial because if these qubits can work well together, it means they are ready to be part of a much larger system. Over time, Microsoft plans to keep adding more qubits until they reach their big goal of 1,000,000 qubits, which could help us do things like find new medicines, protect the environment, and much more. Thanks for exploring the future of computing with us. Don't forget to hit that subscribe button to stay updated with more amazing tech insights.